Okay, YouTube, in this video we're just going to basically confront what we refer to as the common logarithm. And so just as we often have some default settings, it's kind of like with radicals, something like this here. We could also write this as the square root with a little 2 on the outside. And so we often don't do this because we just assume that you mean the square root if you don't write it. Or kind of like, we kind of know you mean 1 times x, we don't write that, or that's to the first if you have no exponent written. So just like all of these things are true, because 10 to the power of something, like, powers of 10 are so common, sorry for the pun here, but common log is what we have. So then what we get is this log base 10 that we see pop up all the time. So we say the function y equals, or f of x equals log base 10 of x is usually expressed as f of x equals log of x. And so you notice that this log of x is the same thing as log base 10 of x, and we just know that if you don't write that there, we know you mean the common log. And whenever somebody refers to the common log, they mean the log with a base of 10 specifically. So let's take a look at an example here, excuse me, in which we have a common log model. And so that's all this is right here. We've got a function that is a model for some data, say. So let's look at what each x and y represent here. We say the percentage of adult height attained by a boy who is x years old can be modeled by this right here, where x represents the boy's age from 5 to 15, and f of x represents the percentile of his adult height. So approximately what percentage of his adult height has a boy attained at age 8? So here's the deal. Let's look at the question first. What percentage of his adult height? Percentage of adult height. So we want to find this, and what I notice here is that this is the y value. So we're going to write this here. We say percent of adult height. I'm going to try to write smallish here. And then we say x. X is the age, I guess, age of the boy, and I don't have to write the restriction here, but between 5 and 15 here. So I guess we could say that all ordered pairs here are age and then percent of adult height. And I think it's also sort of beneficial to at least draw a little rough sketch here of what you're looking at here. We say as the age of the boy goes, we have the percent of adult height. I won't write the H there, adult height. And so the neat thing about this is, well, I know it's a logarithmic model. Not going into this much here, like, this shifts up 29, and, it's vertically stretched by a factor of 48.8 here, and it goes left 1, whatever. But we have some logarithmic model here that's showing this. But what we want to do is this. We've been given here an age. So we know the x value. Essentially, what we're getting here is we're getting the x value 8. And what we want to do is we want to plug that into our function, and we want to find out, well then, hey, what would be the percentage of the adult height? So the good news is we have a calculator that's going to do it for us. We're just going to, maybe make a table of values here. We say x, f of x, and we're going to plug in 8 into our function here. So we get 29 plus 48.8 log, common log, and then we say x plus 1, and our x value here is 8, ocho. Okay, so here we go. We're just going to grab our calculators, you guys. And so your calculator likely has 2 log buttons on it, your natural log and your common log. And your common log, look what's behind it, says 10 to the power of. And your natural log, look what's behind it, e to the power of. These are inverses of each other, but we say log. If I were to type this in now, I say 29. This is all you do. You say 29 plus, and we'll say 48.8 common log. So we say log, and it knows it's common log, and this would be a common log of 8 plus 1, which is 9. And we'll put an end parenthesis on this. And so we get this here, 75 point, let's do 2 places here, 75.57. So I'm going to say approximately, switch over to red here, 75.57 would be the height of this value here. We would have some data point on our graph at 875.57, and possibly there. And that would answer our question here. We also could draw the conclusion that it would be 75.57, and we would say, well, what is this being measured in? Well, it's a percent. So we'd say that's the percentage of the adult height they will have, and they have it at the age of 8, okay? So I would encourage you to now try, how about at the age of 10? Go back, plug in a 10, and see what you get here. But yes, common logs, base 10 all of the time. Cheers.